NEC 210.10.3 states that branch circuits rated 20 amps or less shall supply only the receptacle outlet specified in 210.52b and lighting outlets and other outlets not exceeding 1500 volt amps. NEC 210.23 addresses branch circuits and dwelling units. Firstly, not less than one 15 or 20 amp branch circuit shall be provided to supply the laundry receptacle outlet required by 210.52 F2, and it is not to be shared with other outlets. Secondly, bathrooms, in addition to the requirements of 210.10.3, at least one 20 amp branch circuit shall be provided to supply lighting outlets and receptacle outlets in the bathroom or bathrooms. NEC 210.10.3 prohibits 20 amp circuits from supplying general purpose receptacles, but it does not prohibit them from supplying lighting outlets. NEC 210.23 ATWA requires a 20 amp circuit for bathrooms, which must supply both lighting outlets and receptacle outlets. This means that both the light and fan in the bathroom can be connected to the same 20 amp circuit. The inspector's interpretation of NEC 210.10.3 and 210.23 may be incorrect. 20 amp circuits can be used for both lighting outlets and receptacle outlets in bathrooms. To elaborate further, let's delve into a more detailed explanation of these code sections and their implications for bathroom wiring. The National Electrical Code, or NEC, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It's updated every 3 years to reflect the latest advancements in technology and best practices. Understanding the specific sections related to bathroom circuits is crucial for both electricians and inspectors to ensure compliance and safety. NEC 210.10.3 is designed to prevent overloading of smaller branch circuits. By limiting 20 amp circuits to specific receptacle outlets and lighting outlets, it ensures that these circuits are not used to power a large number of high-demand appliances simultaneously, which could lead to overheating and potential fire hazards. However, it's important to note that this section does not prohibit the use of 20 amp circuits for lighting outlets, as long as the total load on the circuit does not exceed 1500 volt amps. NEC 210.23 ATWA specifically addresses the requirements for bathroom circuits and dwelling units. This section mandates that at least one 20 amp branch circuit must be provided to supply both lighting outlets and receptacle outlets in the bathroom. This requirement recognizes the unique electrical demands of bathrooms, which often include the use of hairdryers, curling irons, and other high wattage appliances. By requiring a dedicated 20 amp circuit, the code ensures that these appliances can be used safely without overloading the circuit. Now let's consider the specific scenario of wiring a light and fan in a bathroom. According to NEC 210.23 ATWA, both the light and fan can be connected to the same 20 amp circuit, as long as the total load on the circuit does not exceed the circuit's capacity. In most cases, the combined load of a light and fan will be well below the 20 amp limit, making it perfectly acceptable to wire them together. However, it's essential to calculate the actual load of each device to ensure that the circuit is not overloaded. To calculate the load of a lighting fixture, you need to know its wattage. For example, a 100 watt light bulb draws approximately 0.83 amps at 120 volts. To calculate this, divide the wattage by the voltage. 100 watts divided by 120 volts equals 0.83 amps. Similarly, to calculate the load of a fan, you need to know its wattage or amperage rating. This information is typically found on a label on the fan motor. For example, a fan that draws 1 amp at 120 volts has a load of 120 volt amps. To calculate this, multiply the amperage by the voltage. 1 amp multiplied by 120 volts equals 120 volt amps. Once you know the load of each device, you can add them together to determine the total load on the circuit. For example, if a light fixture draws 0.83 amps and a fan draws 1 amp, the total load on the circuit is 1.83 amps. To determine the maximum load that a 20 amp circuit can handle, you need to multiply the circuit's amperage by the voltage. In a typical 120-volt circuit, a 20-amp circuit can handle a maximum load of 2400 volt-amps. 20 amps multiplied by 120 volts equals 2400 volt-amps. However, it's important to note that the NEC recommends that you do not load a circuit to more than 80% of its capacity. This is to prevent overheating and potential fire hazards. Therefore, the maximum continuous load that a 20-amp circuit should handle is 1920 volt-amps. 2400 volt-amps multiplied by 0.8 equals 1920 volt-amps. In addition to calculating the load on the circuit, it's also important to consider the type of wiring used. The NEC specifies the minimum wire gauge that must be used for different circuit sizes. For a 20-amp circuit, the minimum wire gauge is typically 12 American wire gauge or AUG copper wire. However, depending on the length of the circuit and other factors, a larger wire gauge may be required. It's also important to ensure that all wiring connections are made properly and that all devices are properly grounded. Improper wiring connections can lead to overheating and potential fire hazards. Proper grounding is essential for preventing electrical shock. In summary, the NEC allows both the light and fan in a bathroom to be connected to the same 20-amp circuit, as long as the total load on the circuit does not exceed the circuit's capacity and all wiring is done properly. It's essential to calculate the load of each device, use the proper wire gauge, and ensure that all wiring connections are made properly. If you are unsure about any aspect of bathroom wiring, it's always best to consult with a qualified electrician. Now let's address the issue of the inspector's interpretation of the NEC. As mentioned earlier, the inspector's interpretation of NEC 210.3 and 210.23 may be incorrect. If the inspector is insisting that the light and fan cannot be connected to the same 20-amp circuit, it's important to respectfully challenge their interpretation and provide them with evidence to support your position. You can do this by providing them with a copy of the NEC sections in question and explaining how they apply to the specific situation. You can also consult with other electricians or electrical inspectors to get their opinions on the matter. If you are still unable to resolve the issue with the inspector, you may need to file an appeal with the local electrical authority. In most jurisdictions, there is a process for appealing an inspector's decision. The appeals process typically involves submitting a written appeal to the electrical authority and attending a hearing where you can present your case. It's important to gather as much evidence as possible to support your appeal, including copies of the NEC sections in question, calculations of the load on the circuit, and opinions from other electricians or electrical inspectors. As for the re-inspection fee charged by the inspector, it may be unjustified if the inspector's interpretation of the NEC is incorrect. If you believe that the re-inspection fee is unjustified, you can challenge it by filing a complaint with the local electrical authority. The complaint process typically involves submitting a written complaint to the electrical authority and providing them with evidence to support your claim. It's important to keep in mind that electrical codes and regulations can vary from jurisdiction to jurisdiction. Therefore, it's essential to consult with the local electrical authority to determine the specific requirements in your area. The NEC is a complex document, and it can be difficult to interpret some of its provisions. Therefore, it's always best to consult with a qualified electrician or electrical inspector if you have any questions or concerns about electrical wiring. To further clarify the application of these NEC sections, let's consider some additional scenarios. Suppose you have a bathroom with a vanity light that draws 150 watts, a ceiling fan that draws 75 watts, and a receptacle outlet that is used to power a hairdryer that draws 1500 watts. In this scenario, the total load on the circuit would be 1725 watts. 150 watts plus 75 watts plus 1500 watts equals 1725 watts, which is equivalent to 14.38 amps at 120 volts. Since the total load is less than the 80% threshold of a 20-amp circuit, which is 1920 volt-amps, it would be acceptable to wire all of these devices to the same 20-amp circuit. However, it's important to note that the hairdryer is a high-wattage appliance, and it could potentially overload the circuit if other high-wattage appliances are used at the same time. Therefore, It's always a good idea to avoid using multiple high wattage appliances on the same circuit simultaneously. Now let's consider a scenario where you have a bathroom with a heated floor that draws 1200 watts, a vanity light that draws 100 watts, and a receptacle outlet that is used to power a curling iron that draws 800 watts. In this scenario, the total load on the circuit would be 2100 watts. 1200 watts plus 100 watts plus 800 watts equals 2100 watts, which is equivalent to 17.5 amps at 120 volts. While the total load is less than the maximum capacity of a 20 amp circuit, it exceeds the 80% threshold of 1920 volt amps. Therefore, it would not be acceptable to wire all of these devices to the same 20 amp circuit. In this case, you would need to either reduce the load on the circuit or install a separate circuit for the heated floor. It's also important to consider the location of the receptacle outlets in the bathroom. The NEC requires that all receptacle outlets in bathrooms be ground fault circuit interrupter, or GFCI, protected. This is to protect against electrical shock in wet environments. GFCI protection can be provided by using GFCI receptacle outlets or by installing a GFCI circuit breaker in the panel. In addition to GFCI protection, the NEC also requires that all receptacle outlets in bathrooms be located at least 3 feet away from the edge of the sink. This is to prevent water from splashing onto the receptacle outlets and creating a shock hazard. When wiring a bathroom circuit, it's important to use the proper wiring methods. The NEC specifies the types of wiring that are permitted to be used in different locations. In bathrooms, non-metallic sheath cable, or NM cable, is typically used for wiring receptacle outlets and lighting outlets. However, in some cases, conduit may be required. It's also important to ensure that all wiring is properly secured and protected from physical damage. Wiring that is exposed to physical damage should be run in conduit or protected by other means. In conclusion, wiring a bathroom circuit requires careful attention to detail and a thorough understanding of the NEC. It's essential to calculate the load on the circuit, use the proper wire gauge, ensure that all wiring connections are made properly, provide GFCI protection, and follow all other applicable code requirements. If you are unsure about any aspect of bathroom wiring, it's always best to consult with a qualified electrician. Remember that electrical safety is paramount, and it's always better to be safe than sorry.